Hi there, another entry in my series of inexpensive multimeters with more than 2000 counts displays, measure volts and current, are reasonably safe and not smart because for sensitive electronics, smarts still have some issues. This here is the TMM-569A which TESMEN has kindly sent into the channel for review. I'm not paid for the video, but since I'm allowed to keep the meter, I mark it as a promotion. From previous reviews, you know that this doesn't stop me from sharing all my findings with you. From the box, it has flashlight, 4000 counts, NCV and is manual as opposed to smart. So what's in the box? A nice pouch and a manual. The manual is in 6 languages and well translated. It covers every type of measurement, but only briefly, assuming at least some familiarity with using a multimeter, not a manual for absolute beginners. The pouch contains a set of 3 AAA batteries, a set of leads and a thermocouple with 2 banana plugs, and the meter, of course. The meter comes in a green protective sleeve which feels a lot more substantial than the rather thin protection offered by, for example, the MoPilot 17B. It has the usual moldings for attaching the probes and you could hang it, but any other hardware for hanging, like magnets, you have to provide yourself. The battery compartment is held with a single screw which goes into a metal threaded insert. But the screw is not held captive and it can get easily lost. The compartment is just for the 3 AAA batteries, no access to fuses. Turning it on shows a rather nice display, large numbers and a bar graph, both very easy to read. A very bright backlight and a torchlight that can be very useful when trying to investigate power fail in the dark. A closer look at the leads that come with the TMM-569A. The tips have shrouds that expose only the last bit at the end, which is in accordance with regulation. It reduces the chance of accidental shorts when probing in tight spaces. They can be removed if that protection is not needed. Since we're at it, let's check continuity. On this meter, this is together with diode tests, not with ohms. There is a LED that lights up when continuity is detected, but as you can plainly see and hear, detection is rather terrible. Often this is caused by a very thin film of grease that was added to prevent corrosion of the steel tips. To see if that's the case here, I use alcohol to clean the tips. The problem with that is of course that the corrosion protection is also gone. Let's see if it helped at least. It definitely did. Still not brilliant, but much better than before. The probes are not branded and rated for 10 amps max. There are no markings on the wires and they are rather stiff PVC. I always try a pair of alternative leads like these from Pomona. Other brands are available, but I just like them and they have never let me down. The wires are also much more flexible. Anyway, as you can see, the Pomonas improve the response even further. One should always consider upgrading no-name leads. Usually that investment makes the meters much more usable and responsive. I would rate the effort in removing and later reinstalling the protective sleeve as similar to, for example, the Bryman, and definitely a lot easier and faster than with the MoPilot. Opening requires the removal of 4 self-tapper screws, 1 in each corner. No need to remove batteries first. It comes apart easily. As with many modern meters, it feels rather empty. Immediately noticeable are the 2 large ceramic high rupture fuses. That's a good sign. The top one is for the milliamp and microamp range and rated 400 milliamps 250 volts. The other one is a 10 amp 250 volt fuse. The rest of the protection is less impressive, but at least not worse with what you get these days. 2 PTCs and the usual diodes. At least the input resistors are put in series to increase their voltage rating. What I don't like is a rather tiny 5 milliohm SMD resistor that has to handle the 10 amps, which is why the manual states a maximum measurement time of 15 seconds for large currents, without explaining what they consider a large current. The brain is an unidentifiable blob, at least the large chip next to it is a TM-1612, which is, unsurprisingly, the LCD controller. I'm always curious about high rupture fuses I find in meters and other devices. This 400 mA fuse weighs 2.2 grams. The 10 amp fuse, also rated for 250 volts, is about 2.29 grams, and the genuine RS Pro 10 amp fuse puts 2.38 grams on the scale. I think that means the TMM-569A fuses are probably okay. A quick run through my test results of the TMM-569A, starting with DC volts. The spec says plus minus 0.5%, and it does that. Just. It is almost expected nowadays that a multimeter is a lot more accurate than its specs, and my recently tested meters all do that, so the TMM-569A just meeting them is a bit disappointing. In practice, however, it isn't really noticeable since handheld multimeters are not normally used for super precision measurements. I checked the input resistance and it meets the 10 megohm specification. AC volts, and the meter has no problems meeting its specs. While the TMM-569A has a DC millivolt range, there's no such thing or AC, which makes it less useful if you want to measure really low AC volts. It beats its specified bandwidth. Measuring down to 10 Hz was no problem, and on the high side the 3 dB point is at nearly 4 kHz. DC amps and AC amps are fine, no problems, and the measured burden voltages are typical for such meters. In case you wonder about the 50 milliohm resistance in the 10 amp range when the shunt resistor is just 5 milliohms as we have seen, this is because the 10 amp fuse is in the path. Resistance is fine, the upper limit is 40 megohm. The reason why the accuracy takes a nosedive on the lower end is a result of the limited resolution. At the low end, the meter has 0.1 ohm resolution. A one-digit error at 100 ohms means 0.1% error. At 10 ohms, the same error becomes 1%, and at 1 ohm, 10%. Lastly, frequency and capacitance. Frequency works very well. I could go all the way to 33 MHz with just 1 volt arm as input. The bounciness of the graph is the result of the meter changing range. Capacitance accuracy is actually very impressive compared to other meters. But for large values, the meter is very slow. Here I am measuring a relatively modest 2000 microfarad cap, and it takes 10 seconds before a first value appears and 30 seconds before it's kind of stable. If you are sitting here holding probes to a cap, that feels like an eternity. Small values are fast and quite accurate. 1.4% from the nominal 1 nanofarad, where the cap itself has a 1% tolerance. Nominal 200 picofarad made out of 5 1 nanofarad 1% caps in series, and the meter shows 195. Not bad. While we are at the topic of speed, let's look at the Autoranging speed using resistance mode. With nothing connected, the meter has upranged to the 40 megohm maximum. Downranging to measure 1 ohm takes about 3 seconds. Kind of average. There are faster meters but also much slower ones. To get an idea on the measuring speed in general and the display and the bar graph update rates specifically, I fed the meter with a sawtooth voltage ramp at 1 Hz. It is very obvious that the TMM-569A updates the bar graph and the readout at the same time, roughly 3 times per second. For comparison, the Fluke updates its display only 2.5 times per second, but its bar graph 25 times per second. Moving on to diodes. It measures a normal diode just fine. No beeps in forward direction. 2 diodes in series is no problem. Measuring 1 red LED works fine, but 2 red LEDs in series cannot be measured or lit up. 1 yellow LED works with a forward voltage of just above 1.9 volts. 1 white LED lights up, but the forward voltage is not displayed. Looks like 2 volts is the limit in diode mode. The accuracy on the temperature readings depends of course mostly on the probe. To see what the basic accuracy of the meter itself is, I use a calibrator instead of a probe. The TMM-569A thinks its cold junction is 25 degrees Celsius, which is about 2 degrees Celsius more than ambient, probably because it was running for quite some time. I set the calibrator to base its output on the same temperature. And sure enough, as the calibrator is currently stimulating 0 degrees Celsius, the TMM-569A goes to 0 as soon as it's plugged in. Trying a few values, the TMM-569A follows the calibration nicely. There is a deviation of 1 degree at very high temperatures, and 1000 degrees or 1832 degrees Fahrenheit is the highest value the meter allows. On the negative temperatures, the error of 1 degree occurs earlier, and the highest negative value seems to be minus 20 degrees Celsius or minus 4 degrees Fahrenheit. I am in general not a fan of NCV multimeters because they tend to be too bulky for probing in tight spaces that have many cables, but let's see how the TMM-569A is doing. Okay, it works, but the sensitivity isn't great. You almost have to touch the cable with the antenna. This is a bit surprising, as TESMEN knows how to make good NCV testers, as demonstrated by the TN213 here, which I reviewed some time ago. Sensing the live wire works with no problem. You must only use the red lead here and ensure that the black one is not plugged into the meter, because when doing this test, the black terminal is capacitively coupled to live and you could certainly get an unpleasant tingle from touching it, potentially worse. A rather unique feature of the TMM-569A is that it can measure the direction of phase rotation in a 3-phase AC system. Similar to the live measurement, it uses only the red probe. The P with a blinking A means the meter is waiting for you to touch the first phase with a red probe. Then the display will show PA with a blinking B for the next phase, and so on. After C, it will show left or right phase sequence. As I don't have a 3-phase system handy, the phase measurement times out after 1 minute. Rather to my surprise, spurious interference did make this work, and by sheer luck I had the camera running. So here is what you would see conducting an actual phase sequence measurement. Apparently, the interference produced a left rotating phase sequence. Nearly all budget meters these days have trouble with autoranging when faced with combined AC plus DC signals with voltages that fall into different ranges. Here is a 50 Hz square wave signal with a duty cycle that slightly extends the positive part. As the red meter shows on its dual display, this results in an AC component of 11.7 volts and a DC component of about 2.4 volts. The TMM-569A has no problem showing the AC part. But when I select DC, it can't settle on a range, because obviously it should be 4 volts, but that's causing an overload on the AC part, so it selects 40 volts, but then DC wants to downrange back to 4 volts, and so on. Increasing the duty cycle further pushes the DC part over 4 volts, and now AC and DC can happily live with a 40 volt range. This is a very common problem in many multimeters. Lastly, a quick look at power consumption. I'm feeding the TMM-569A from my bench power supply. The blue meter shows the current and the red one the voltage. The current draw is between 1.9 and 2.5 milliamps depending on the function, which is no problem. Turning the torch light on increases this to 17.6 milliamps. Torchlight and backlight together consume 35.5 milliamps. The backlight alone brings it to 20.4 milliamps. As with many multimeters, one of the biggest consumers is the beeper. With 34 milliamps, just the beep alone consumes nearly as much energy as the backlight and torch combined. I did not video this, but with the beeper blaring and both backlight and torch on, the current is nearly 70 milliamps. The sleep current after EPO is just 13 microamps. reducing the voltage to see when the battery low symbol appears on the upper right of the display. It happens pretty much exactly when the voltage drops below 3.5 volts. This is excellent news because it allows you to use rechargeable batteries. With 3 rechargeable batteries you get a pretty constant 3.6 volts until they are nearly exhausted, so a 3.5 threshold will work nicely. I was trying to check how long the backlight stays on, expecting the usual 15 seconds or so, but I gave up after 3 minutes and counting. Yes, in this meter the backlight stays on as long as you want. Okay, if APO is not disabled, it will turn off together with the meter after 15 minutes of inactivity, but finally you are not constantly struggling with a backlight that turns off right when you finally manage to probe the thing you wanted to measure. Think of working under a car dashboard. Finally, with a bit of wiggling, it's possible to store the manual in the pouch and then stack everything else in it as well. While I'm doing it, let me thank TESMEN for sending it in and sum up the TMM-569A. Starting with my nickels, and every meter has some, the key one is that while the DC volts accuracy is in spec, we have come to expect that in reality meters beat their specs, and the TMM-569A does that too for other ranges, so why not for DC volts? Sadly, there is no AC millivolts mode, which limits the available resolution for small AC voltages. The small SMD resistor as a shunt for the 10 amp range could cause it to be thermally stressed if you are not careful. The meter has the usual issues with combined AC plus DC signals, and unlike other meters with the same problem, there isn't a manual range function that would help in such cases. Lastly, the NCV is not very sensitive, but as I said, I don't recommend using multimeters for that anyway. On the positive side, the display is large, easy to read at all angles, and it has a bar graph. It would be even better if the bar graph could update faster than the display, but there we are. There's no backlight timeout. I think this is the only meter I've ever used that has this feature. And what a relief it is when you really need backlight. Can we please have this on other meters as well? Specs are reasonable and capacitance mode is actually pretty good, but rather slow. There's a 3-phase sequence mode that may be really important to a few, but most people, me included, will never need it. Safety features are fair and the fuses are decent, but I would still recommend not using this meter on Cat4 and be extra cautious on Cat3 circuits. It is very welcome that this meter uses AAA batteries instead of 9 volts, and you can use rechargeable ones too. The built-in torch can be very handy when probing in dark areas, for example under a car dashboard. All in all, I like the TMM-569A, and for household use and around the garage, this meter is a good choice. If you enjoy my videos, don't forget to like and subscribe. There are many more projects, repairs and reviews coming up, and it would be great if you decided supporting this channel by becoming a Patreon. Thanks for watching.